TLT-Turbo is continuously working on research and development topics to increase our customer benefits. We always try to think outside of the box. And one example what we can achieve in this thinking is our new product, the MoJet.
As a designer of tunnel ventilation systems, I was frustrated by the fact that jet fans are inherently inefficient, typically losing between 30 to 50% of their thrust through friction between the jet and neighboring tunnel surfaces. What we needed was a compact solution of how to deflect the jet without reducing the bench thrust or increasing the power consumption or noise. That solution is the MoJet.
The big difference from a conventional fan is this special shape of the inlet and outlet cross-section.
Due to the inclination of the MoJet nozzle, we achieve that the jet stream is led to the middle of the tunnel without any separation. Due to this inclination of the jet stream, we have reduced friction losses between the jet stream and the road tunnel ceiling. The first step was to carry out several CFD calculations to prove the concept in a very early state.
The CFD analysis showed us that the MoJet ticked all the boxes we needed. It provided about 30% more thrust in a tunnel, whilst not compromising its performance on a bench. But the idea still needed physical testing in case there were any physical effects that we did not capture via CFD.
Therefore, we produced a small jet fan in the size of 70 millimeters and tested it in that scale. We all know that theory and simulation are one thing, but we wanted to take it one step further and do the ultimate test.
We're standing here in the Rendell Street branch of the Mersey Queensway Tunnel to test our innovative new ventilation method for tunnels, which is the MoJet. And we're going to compare this technology with the standard technology, which is a standard conventional jet fan.
When we test the jet fan in our laboratory, we are only able to measure the thrust without any frictions. But here in a real tunnel, we have frictions due to the walls, to the soffit, to the road.
It's important when we do this that we actually work out what is the net effect of this thrust. Because at the end of the day, we're not really interested in the thrust. We're interested in air velocity. We're interested in the effect, not the source. And in measuring these air velocities, we'll work out whether this new innovative technology actually works or not.
We expected 20% thrust increase. The test in Liverpool exceeded those high expectations with almost 30%.
For this tunnel, this would mean that designers can specify 30% fewer jet fans while still achieving the required in-tunnel thrust. Alternatively, if the same number of jet fans is used, the power consumption can be reduced by 30% by decreasing the blade pitch angle. At a time when sustainability and energy efficiency are key drivers for public infrastructure, I believe that the MoJet is part of the solution for longitudinal tunnel ventilation.
We are very excited and look forward to take your tunnel ventilation to the next level.